Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello. It's great to discuss this fascinating area of research. To start, could you explain the significance of hierarchical structures in text classification and how they differ from traditional flat classification methods?
Hierarchical structures in text classification are like a family tree, where each family member has a specific role and is connected to others. In this case, the family consists of labels that help organize documents. Each label can have parent and child relationships, meaning some labels are broader categories while others are more specific. On the other hand, traditional flat classification methods treat each label as a separate individual, much like a group of people standing alone, without connections to each other. This can lead to challenges because, in a flat approach, the relationships between categories are ignored. One significant issue with flat methods is that performance metrics like precision and recall assume these labels are independent. This means that if a classifier makes a mistake with a child label, but gets the parent label right, the performance may still appear good. However, in reality, it's more important to understand these relationships, as misclassifying a child label can indicate a deeper issue within the classification system. Hierarchical classification methods aim to address these problems by recognizing and utilizing the relationships between labels, which can lead to better accuracy and more meaningful insights when classifying documents.
That's a compelling analogy. Moving into more technical aspects, could you elaborate on the specific traditional approaches to hierarchical text classification mentioned in the study? How do these methods generally operate? And what are some of their strengths and weaknesses?
Traditional approaches to hierarchical text classification can be likened to different strategies in a relay race. Each strategy has its own strengths and weaknesses, and choosing the right one depends on the specific race conditions. One common method is based on support vector machines, SVM. Imagine SVMs as runners who focus on individual checkpoints along the track. While they can establish clear boundaries between categories, they often struggle with complex and deep hierarchies where relationships between categories matter. These methods can still be useful, especially in noisy environments, as they are relatively easy to implement. However, they might not deliver the best performance compared to more specialized hierarchical methods. Another approach utilizes convolutional neural networks, CNNs. Think of CNNs as runners who can quickly adapt to different terrains, making them versatile. These models can also be beneficial, though they might not always perform as well as more tailored methods. In terms of benchmarks, HIAM serves as a reference point for many researchers, as it offers a good balance between performance and training speed. It's like a reliable runner known for consistency, making it easier to adapt for various tasks. Overall, while traditional methods have their merits, they often fall short in leveraging the hierarchical relationships among categories, which can limit their effectiveness in complex classification tasks.
That's an insightful breakdown. Given the limitations of traditional methods, what recent approaches have emerged in hierarchical text classification, and how do they leverage the hierarchical structure to improve classification performance?
Recent approaches in hierarchical text classification are like new training techniques that athletes are adopting to improve their performance in relay races. These methods recognize the importance of the relationships within the hierarchical structure of categories, allowing them to classify documents more effectively. One emerging technique utilizes the idea of leveraging dependencies between labels. This is similar to how runners might work together in a relay, where each runner's performance can boost the overall team's success. By understanding how labels are related, like parent and child categories, these methods can improve classification performance, especially in situations where many labels are similar or related. Another advantage of hierarchical methods is that they tend to generalize better when faced with new classes. Imagine a team that has trained together for a long time. When a new member joins, they can quickly adapt because they're already familiar with the team's strategies. In a hierarchical classification context, newly introduced classes often fall under existing broader categories, allowing the system to retain knowledge from those parent categories. This helps it make better predictions for the new classes based on what it has learned before. Overall, these recent approaches enhance the ability to handle complex relationships within data, leading to improved accuracy and adaptability in hierarchical text classification tasks.
That's an excellent analogy. Let's dive into the evaluation aspect. Why is it important to use evaluation metrics tailored specifically for hierarchical settings? And how do these metrics differ from those used in traditional flat classification? What impact do they have on assessing the performance of hierarchical classification methods?
Using evaluation metrics tailored specifically for hierarchical settings is crucial because these metrics understand the unique structure of categories and how they relate to one another. It's like having a referee in a game who knows the specific rules for different situations, rather than applying the same rules universally, which may not make sense in all contexts. In traditional flat classification, metrics like precision, recall, and accuracy treat each category as if they stand alone. This can lead to misleading results. For instance, misclassifying a child category might seem less severe than misclassifying a parent category. However, in reality, getting the child wrong could imply a deeper understanding issue, so these mistakes should be weighted differently. Hierarchical metrics are designed to account for these relationships and the severity of mistakes. They help quantify mistakes by considering how far off a prediction is within the hierarchy, much like judging a performance based on how close a runner is to the finish line, rather than just whether they finished or not. While these hierarchical metrics can provide valuable insights, they often do not differ significantly from standard metrics in practice. However, they do allow for a more nuanced understanding of a model's performance in hierarchical classification tasks. Overall, employing these tailored metrics can lead to a more accurate assessment of how well hierarchical classification methods are performing, which is essential for improving and refining these systems.
That distinction is really important. Lastly, could you share some insights about the benchmarking results presented in the study? How did recent hierarchical classification methods perform compared to non-hierarchical baselines across the public domain-specific datasets? And what implications do these results have for the future of research in this field?
The benchmarking results indicate a competitive landscape in hierarchical text classification, showcasing how recent methods stack up against traditional, non-hierarchical baselines. In tests across public domain-specific datasets, methods like HBGL and GCAPS emerged as top performers, effectively using hierarchical information to enhance classification accuracy. However, the performance wasn't uniform across all datasets. For example, while BERT-based approaches showed superiority in the Web of Science dataset, the improvements gained from match and champ losses were minimal or even negative. This suggests that simply integrating hierarchical information isn't always straightforward. It requires careful consideration of how that information is utilized within the model. The overall findings imply that leveraging hierarchical structures can significantly benefit classification accuracy, particularly when compared to traditional flat approaches like SVMS. The results also highlight the importance of semantic understanding in models, as seen with BERT, which contributed to better performance even in the context of hierarchical tasks. These insights point to a promising direction for future research. As researchers continue to explore and refine hierarchical classification methods, there is potential for developing more sophisticated techniques that can effectively combine hierarchical information with semantic capabilities, leading to even greater improvements in classification tasks.
Thank you to our esteemed researcher for sharing their insights on hierarchical text classification. Key points to remember. Hierarchical structures enable more accurate classification by leveraging parent-child label relationships. Traditional methods like SVMs and CNNs can be adapted for hierarchical classification. Recent methods emphasize label dependencies and generalization, leading to improved performance. Specialized evaluation metrics are essential for accurate assessment of hierarchical classification methods. Benchmarking results demonstrate the effectiveness of recent hierarchical approaches. Further research is promising in combining hierarchical information with semantic capabilities to enhance classification accuracy. Thank you all for your engagement in this discussion. We look forward to continuing the exploration of hierarchical text classification and its applications in the future.